Good morning, everybody. Today we're going to be doing the Cornell review for Chapter 6. So you should all have one of these yellow sheets, the Cornell sheet in front of you. Make sure you put your name on it. As always, I will be collecting this for your test tomorrow. And the heading for this one is going to be Chapter 6 Review. So the very first topic is the angle sum theorem, and that was this thing, the n minus 2 times 180. So I'm going to do one example of this, and here it is. A convex pentagon has interior angles with measures x plus 20 degrees, x plus 5 degrees, x plus 10 degrees, and x degrees. And we want to find x. So the first thing we have to do is figure out how many total degrees are in a pentagon. Well, a pentagon has what, 5 sides? So if we go 5 minus 2 times 180, that's the same thing as 3 times 180, we will find that the total degrees in a pentagon is 540. So that's what we're going to set this equal to. All right, don't always assume that it's going to be either 180 or 360 because that's not always the case. We have to figure out the total degrees in our pentagon. All right. Oop, I think I mixed one. Oh, I did miss one. Oh, shoot. There's an x minus 5 as well. I'm like, wait, I only have 4 angles here. Okay, so if we add all these angles together, x plus 20 plus x plus 5 plus x plus 10 plus x plus the last one that I just added, x minus 5, that equals 540. Okay, so we're going to combine like terms. We have what? 1, 2, 3, 4, 5 x's. So 5x equals 20 plus 5 is 25, plus 10 is 35, minus 5 is 30. All right, so if we subtract that 30 over, 5x equals 510. And then when we divide, looks like x is 102. All right, so that's using angle sum theorem. The next one, dealing with exterior angles. Find the sum of measures of the exterior angles of a convex 23 gon. Well, in a way, this one's kind of a trick question, because what's the measure, or what's the total degrees of exterior angles in any polygon? It's 360, right? So, doesn't matter if it has 23 sides or if it has 3 sides, it's going to be 360 for exterior angles. All right, parallelograms. I'm going to do one example for parallelograms. Nope, I lie. 2 examples. The first one's short. In parallelogram MNOP, the measure of angle M is 64. We want to find the measure of angle N. Well, parallelogram MNOP. Well, if M is 64, wouldn't these two be supplementary right here? So 180 minus 64 looks like 116. Okay, because we know the consecutive angles are supplementary in a parallelogram. Second one, find the coordinates of the intersection of the diagonals of parallelogram MNPR with M negative 3, 0, N negative 1, 3, P 5, 4, and R 3, 1. Okay, so if we just draw like a rough sketch of this, we have M, N, P, R, talking about diagonals. Okay, so in a parallelogram, we know that diagonals are going to bisect each other, right? So shouldn't they cross at the midpoint? So that means that we should be able to use the midpoint formula to figure this out. And technically, it shouldn't matter which set of diagonals you use. For example, if I do the midpoint between MP or MNP, it's going to be negative 3 plus 5 divided by 2, 0 plus 4 divided by 2. So 2 over 2 and 4 over 2 looks like we get 1, 2. Okay, now watch. What if I use the other diagonals? So I want to find the midpoint between N and R. So negative 1 plus 3 squared and 3 plus 1 squared. So we get 2 over 2, 4 over 2. Look at that. It doesn't matter. You can pick either one. Okay? All right. Rectangles. I'm going to do just one example for rectangles. And here it is. Given rectangle L, M, N, P, we want to find X. And M, N, L, P. That and this diagonals. This angle right here, 5x plus 8. This angle right here, 3x plus 2. Okay, so rectangle. What makes a rectangle are what? The 4 right angles. Okay, so these two are going to add up to 90. 5x plus 8 plus 3x plus 2 equals 90. All right, let's combine like terms. We get an 8x plus 10. Subtract the 10 over. We get 8x equals 80. Looks like x is 10. And it looks like we're done because it just said find x. Nice. Okay, squares. I'm going to do one example for squares as well. Here we go. The diagonals of square A, B, C, D intersect at point E. If AE equals 2x plus 3 and BD equals 10x, find AC. Well, it might be helpful to draw a picture for this guy. Oops, it's a square. Whoops-a-daisy. I was starting to draw a rectangle. All right, diagonals. If we have A, B, C, D, and they intersect at E. Okay, so AE is 2x plus 3. This whole thing here is 10x. We want to find AC. Well, in a square, the diagonals are going to be congruent, right? Because a square is a rectangle, and rectangles, the diagonals are congruent. Also, in a square, the diagonals are going to bisect each other, because a square is also a parallelogram, so the diagonals are going to bisect each other. So this one plus this one is going to equal this whole thing. So if this is 2x plus 3, so is this part. So we're going to go 2x plus 3 plus 2x plus 3, or you can think of it as times 2, so like 4x plus 6, equals 10x. Okay, so combine like terms. 4x plus 6 equals 10x. Subtract that 4x over, and we get 6 equals 6x. So it looks like x is 1. But we're not done, because this one, it did ask us to figure out what AC is. Okay, so let's go back and substitute it in for here. So 2 times 1 plus 3, that would be like 2 plus 3, so 5. Okay, so this means that whole thing, if this is 5 and this is 5, that means the whole thing is 10. The other way you could have looked at that is that you know that B and D, or BD and AC are the same, so if this one's 10x, so is this one. So either way, you get 10 as your answer. Okay. All right, next one. We're going to do one example for trapezoids, and then on the second side, we'll take a look at some more trapezoid things. Okay, so for isosceles trapezoid, W, X, Y, Z, we want to find the measure of Z, W, Y. Here's a picture. W, X, Y, Z. Draw in diagonals. We know that, or we're given that this is 40, that's a 40, and this one is 30. So we have a 30 and a 40. I know that's really little. Here, let me zoom in a little bit here and see it maybe a little bit better. It's still really blurry. Okay, so we have a 40 and a 30. All right, so this whole thing is 70. All right. Now, if this is an isosceles trapezoid, that's true. That means that base angles are going to be congruent, right? So we have 40 and 30. We want to find ZWY. So we want to find this one right here. Okay. If these two are 30, what would this one have to be? 120? Okay. So that would mean that this one is 60. Now do you see it? In this triangle right here, we have Z, W, Y. This is 40, this is 60. It's got to be 80. Okay, so you had to use some of your triangle skills for that one. All right, this video is going to stop. Give you a second to catch up on some stuff, and then we'll play part 2, and we'll do the second side of this Cornell review. So I'll see you in just a moment.